Welcome to Astro Odyssey. Explore the universe. The exploration of the abyss begins with a fundamental shift in how we perceive the vacuum of space. Far from being an empty stage, the universe is a dynamic, hungry entity, and the black hole is its most voracious expression. To call a black hole a dead star is a profound understatement. It is a gravitational anomaly that has successfully waged war against the very forces that hold matter together. When a massive star exhausts its nuclear fuel, it can no longer support its own weight against the relentless pull of gravity. The resulting collapse is so absolute that it punctures the four-dimensional manifold of our reality. This rupture creates a region where the escape velocity exceeds the speed of light, ensuring that anything crossing its border is effectively deleted from the observable universe. This boundary, known as the event horizon, serves as a one-way threshold where the future of all matter points toward a singular, unavoidable destination. As an observer approaches this gravitational shadow, the distortion of space-time produces effects that challenge our most basic intuitions about distance and duration. Light from distant stars is bent into glowing rings, and time itself begins to dilate. If you were to watch a traveler fall toward a black hole from a safe distance, you would see their movements slow to a crawl, eventually freezing at the horizon's edge, reddening until they fade into invisibility. But for the traveler, their experience is one of horrific acceleration. This leads to the gruesome reality of spaghettification. Because gravity obeys the inverse square law, pull on the traveler's feet becomes exponentially stronger than the pull on their head. In a stellar mass black hole, this tidal gradient is so steep that it overcomes the electromagnetic bonds of human biology, stretching the body into a single atom-wide ribbon of plasma before it ever reaches the center. Recent data from the James Webb Space Telescope, JWST, has transformed these dark icons from mere scavengers into the invisible architects of the cosmos. For decades, the consensus was that black holes grew slowly over billions of years, feasting on stray gas and the occasional star. However, JWST has peered back into the early universe and discovered supermassive black holes that were already billions of times the mass of our sun just a few hundred million years after the Big Bang. These impossible monsters shouldn't exist, according to our traditional bottom-up models of galaxy formation. Their presence suggests that black holes may have been primordial, born not from dying stars, but from the direct collapse of massive gas clouds at the dawn of time. These titans did not wait for galaxies to form. They likely acted as the gravitational seeds around which the first galaxies were woven. At the heart of this architectural darkness lies the singularity, the ultimate death of physics. In the mathematics of general relativity, a singularity is a point where the curvature of space-time becomes infinite and the volume becomes zero. It is the place where the where and when of the universe are extinguished. Here, the light of the universe is not just trapped, it is fundamentally ended. Because the singularity represents a breakdown in our ability to calculate reality. It suggests that our current understanding of the universe is merely an approximation. To peer into the singularity would be to see the place where quantum mechanics and gravity collide in a stalemate. It's the absolute limit of human knowledge. A dark mirror reflecting back our inability to reconcile the very small with the very large, leaving us to wonder if the abyss is not just a place in space, but a fundamental flaw in our perception of existence itself. The transition from the physical violence of black holes to the psychological coldness of the Fermi Paradox represents a shift from the death of matter to the death of meaning. If the universe is a vast, ancient stage spanning nearly 13.8 billion years and containing an estimated septillion stars, the mathematical probability of extraterrestrial life should be a statistical certainty. This is the core of the Fermi Paradox. The staggering discrepancy between the high probability of life's existence and the total lack of evidence for it. We look out into the void and see a universe that appears meticulously clean, devoid of the radio signals, megastructures, or planetary engineering that an advanced civilization should leave in its wake. This haunting silence suggests that the abyss is not just a place where stars go to die, but a graveyard for entire civilizations. One of the most chilling solutions to this paradox is the concept of the Great Filter. This theory suggests that there is a developmental wall so difficult to climb that almost no species survives it. This filter could be located in our past, perhaps the transition from simple single-celled life to complex multicellular organisms is an improbable miracle that occurred only once. However, the more terrifying possibility is that the filter lies in our future. It may be that once a civilization reaches a certain level of technological prowess, discovering nuclear energy, artificial intelligence, or biotechnology, inevitably triggers its own extinction. If the silence is a result of a future filter, then every step we take toward progress is actually a step toward the ledge of a precipice. We may not hear signals from the stars because the life that sent them is already ashdot. Beyond the biological hurdles of the Great Filter lies a darker, more strategic explanation known as the dark forest theory. This hypothesis, rooted in the principles of game theory and cosmic sociology, posits that the universe is not an empty desert, but a densely populated forest filled with armed hunters. In this scenario, every civilization is a predator, and the primary goal of any species is survival. Because you can never truly know the intentions of an alien race, and because the vast distances of space make diplomacy impossible, the most rational move upon discovering another life form is to eliminate it before it can do the same to you. Under the rules of the dark forest, the universe is silent not because it is empty, but because the wise stay quiet. We, by broadcasting our presence through radio waves and golden records on Voyagers, are like children shouting in a forest full of wolves, unaware that our calls are invitations to a slaughter. Alternatively, we may be victims of the zoo hypothesis, a scenario where we are neither the hunters nor the hunted, but merely the exhibits. This theory suggests that advanced civilizations are aware of our existence, but have agreed to a prime directive of non-interference. They watch us from the shadows of the Oort cloud, or from higher dimensions, waiting for us to cross a specific threshold of maturity, technological, ethical, or biological, before they reveal themselves. This creates a different kind of vertigo, the realization that we are living in a curated reality, experimental petri dish, where our history is allowed to play out only as long as it remains interesting or harmless to the observers. Whether the silence is due to our insignificance, our isolation, or a cosmic rule of concealment, the lack of a signal from the stars feels less like a mystery and more like a death knell. It forces us to confront the possibility that the abyss is the natural state of the cosmos, and that life is a fleeting, flickering candle in an infinite wind. If we are truly alone, the weight of preserving the spark of consciousness rests entirely on our shoulders, a responsibility that is perhaps more terrifying than any alien invasion. If we are not alone, then the silence is a warning. The universe is a place where the loud are deleted, and we have already been screaming for a century. The exploration of the cosmic abyss shifts from the localized hunger of black holes to a grander, more systemic movement that suggests the entire universe is built upon a foundation of unseen currents. This is the mystery of the Great Attractor, a gravitational titan that challenges our perception of cosmic autonomy. We often envision the expansion of the universe as a uniform outward flight, a scattering of galaxies like embers from a fire. However, when astronomers began mapping the peculiar velocities of our galactic neighbors, they discovered that we are not merely drifting with the expansion. Instead, the Milky Way and every galaxy within a 250 million light-year radius are caught in a massive, coordinated migration. We are being funneled through the void, participants in a silent, high-speed pilgrimage toward a coordinate in space that we have only recently begun to understand. The horror of this migration is amplified by our own cosmic blindness. The Great Attractor resides in a direction of the sky known as the zone of avoidance. Because our solar system sits within the flattened disk of the Milky Way, our view of the deep universe is bifurcated by our own galaxy's internal structure. The thick, opaque curtains of interstellar dust, gas, and the crowded glare of billions of stars act as a permanent shutter. For decades, this prevented us from seeing what lay ahead of our trajectory. We could feel the tug, a gravitational influence equivalent to tens of thousands of Milky Ways, but the source remained a ghost. It is a form of scientific vertigo to realize that your entire world and everything you have ever observed in the night sky is being dragged at 1.4 million miles per hour toward a destination that remains hidden behind a wall of soot and light. As X-ray and infrared astronomy matured, allowing us to peer through the dust of the zone of avoidance, the whirlpool began to take a more defined shape, though its nature remains no less daunting. The Great Attractor is not a single object, not a mega black hole, or a singular point of density, but rather the gravitational center of the Laniakea supercluster. It is a basin of attraction, a region where the density of matter is so high that it has tilted the local fabric of space-time. Imagine a stretched rubber sheet where most galaxies are small marbles rolling outward. The Great Attractor is a massive heavy weight that has created a deep, sloping valley. We are currently rolling down the side of that valley, along with the Andromeda Galaxy and the thousands of members of the Virgo cluster. Yet, even as we identified the Laniakea supercluster, the mystery only scaled upward. Observations suggest that the Great Attractor itself is being pulled towards something even larger, the Shapley supercluster. This implies a hierarchy of the abyss, where every monster we identify is merely a servant to a larger, more distant force. It raises the terrifying possibility of dark flow, a controversial theory suggesting that a significant portion of the observable universe is being sucked toward a region outside the boundaries of our known horizon. If this is true, the Great Attractor is merely the first ripple in a cosmic drain that leads to a reality we cannot even define. We are caught in a slow-motion whirlpool of such scale that the destination may not be a place at all, the final state of gravitational collapse, that we are fated to join billions of years before the stars themselves burn out. The concept of rogue planets or homeless wanderers introduces a form of isolation that is perhaps more haunting than the violent density of a black hole. In our terrestrial experience, we associate the existence of a world with the presence of a star. We view the sun as a cosmic parent that provides both the gravitational anchor to keep us from drifting and the thermal energy to sustain our chemistry. However, the reality of the abyss is that the universe is a chaotic laboratory of gravitational billiards. During the early, turbulent stages of planetary formation, when gas giants migrate and protoplanets jostle for stability, many worlds are not settled into orbits but are instead slingshotted away. These ejected orphans are accelerated to speeds that allow them to break free from their home stars entirely, casting them into the eternal night of the interstellar medium. These worlds exist in a state of absolute, crushing silence, in the spaces between the stars. The temperature hovers only a few degrees above absolute zero, a realm where the very air of a planet would freeze solid and fall to the ground as crystalline snow. For a rogue planet, the concept of a year or a day is meaningless. There is no sunrise to mark the passage of time, only the cold, distant flicker of stars that will never be close enough to offer warmth. To stand on the surface of such a world would be to experience a level of sensory deprivation that the human mind is not equipped to handle. A world where the horizon is indistinguishable from the sky, and where the only light comes from the one faint, ghostly glow of the galactic center, or the occasional passing nebula yet. Beneath this facade of a frozen tomb, these planets may harbor a resilient internal vitality. The surface is a graveyard, but the core remains a furnace. Through the process of radioactive decay, the breakdown of isotopes like potassium-40, thorium-232, and uranium-238 trapped during the planet's birth. Rogue world can generate significant internal heat for billions of years. If the planet possesses a thick enough crust of ice or a dense layer of molecular hydrogen, this heat can be trapped, creating a subsurface abyssal ocean. In these pressurized, pitch-black waters, the conditions for life might not just exist, they might thrive. This is a form of existence entirely decoupled from the light of a star, powered by the slow-burning embers of the planet itself. The philosophical weight of these orphan worlds is profound. If life exists in these hidden oceans, it would be evolving in a universe that consists entirely of water and rock. These organisms would have no eyes to see stars, no skin to feel the sun, no reason to believe that anything exists beyond their dark, liquid womb. They would be the ultimate inhabitants of the abyss, survivors of a cosmic exile who have turned a death sentence into a sanctuary. As we gaze at the empty spaces between the stars, we must realize we are looking at a crowded neighborhood of trillions of invisible drifters. The rogue planets remind us that the universe does not require a sun to be a home. 8. It only requires the slow, patient decay of matter and the insulating embrace of the dark. While the Big Rip describes a slow, agonizing disintegration of the cosmic fabric, false vacuum decay represents a sudden, absolute altef for command for reality itself. To understand this threat, we must look at the Higgs field, the invisible energy field that permeates all of space and grants mass to fundamental particles. In our current understanding of particle physics, we assume that this field is at its lowest possible energy state, the true vacuum. However, current measurements of the mass of the Higgs boson and the top quark suggest a terrifying alternative. We may be living in a false vacuum. This means the universe is not at the bottom of the energy valley, but is instead caught on a precarious high-altitude ledge, like a boulder precariously balanced on a mountain slope. Our version of reality is stable for now, but it is not settled. The danger lies in a phenomenon known as quantum tunneling. In the quantum realm, particles don't always need to climb over a mountain to get to the other side. They can sometimes simply ghost through the barrier. If at any point in the infinite expanse of the cosmos, a single patch of space undergoes a phase transition and tunnels into the true vacuum, it would trigger a catastrophic chain reaction. This would create a bubble of nothingness, or rather a bubble of a different, more stable reality. This bubble would expand outward in every direction at the speed of light, because the boundary of this bubble moves at the speed of information itself. It is physically impossible to see it coming. There would be no astronomical warning, no flickering of the stars, and no time for a scream. It would simply cease. To be at the exact moment the edge of the bubble reached Earth, as the wall of this vacuum bubble passes through us, it would instantly rewrite the laws of physics. The fundamental constants that govern the strength of gravity, the charge of an electron, and the way atoms bond together would be fundamentally altered or erased. Inside the bubble, the physics of the light that we have spent centuries trying to decode would be replaced by a new alien set of rules. The atoms that compose your DNA, the molecules of the air you breathe, the stars in the sky would be instantly rendered unstable. They would dissolve into an exotic, high-energy plasma, or simply vanish, leaving behind a universe that is perhaps more stable, but entirely inhospitable to the matter we recognize. It is the ultimate cosmic reset, a process that doesn't just destroy life, but deletes the possibility of our chemistry ever existing. This scenario introduces a level of existential fragility that makes even the black hole's delete keys seem merciful. In a black hole, there is a process, a transition, and a place where information is stored or crushed. In false vacuum decay, there is only the before and the nothing. It implies that the entire history of human achievement, every star ever born, and every thought ever conceived is written on a chalkboard that can be wiped clean in a nanosecond by a random quantum fluctuation in deep space. It is a reminder that the abyss is not just out there among the galaxies. It is the very floor. We are standing on. Our existence is a temporary reprieve, a metastable moment in an infinite timeline, waiting for the one random event that will return the universe to its true silent equilibrium. The boat's void, often whispered about as the Great Nothing, represents a level of cosmic desolation that challenges our understanding of how the universe organizes itself. In the standard model of cosmology, the universe is structured like a sponge or a web. Matter is pulled by gravity into long, glowing filaments, leaving behind empty spaces called voids. However, the boat's void is an anomaly of scale, spanning approximately 330 million light-years in diameter. It is one of the largest known supervoids in existence. To put its size into perspective, If the Milky Way were located in the center of the boat's void, we would not have discovered the existence of other galaxies until the 1960s. We would have looked out into a night of near-total blackness, believing our own cluster of stars was the entirety of the creation. Standard calculations suggest that a region of this magnitude should contain at least 2,000 to 10,000 galaxies. Instead, astronomers have detected fewer than 100. This staggering lack of matter has led to the elite boat's void being described as a hole in the universe. Scientists struggle to explain how such a massive volume could remain so empty. Theory suggests that the boat's void was formed by the merging of smaller, localized voids, much like soap bubbles, in a sink joining together to form one giant cavern of air. As these smaller voids expanded, they pushed the surrounding galaxies toward the edges, creating the walls of the void, titanic filaments of matter that act as the boundaries of the great nothing. However, the precision and scale of this emptiness have fueled more speculative, chilling theories that lean into the realm of the Fermi Paradox. Some theorists have jokingly, yet provocatively, suggested that the boat's void is not a natural occurrence, but a cosmic scar, the result of a type is 3 civilizations expansion. According to the Kardashev scale, a Type 3 civilization is one that can harness the energy of an entire galaxy. If such a civilization were to expand outward from a central point, they might hide their presence by constructing Dyson spheres around every star they encounter to capture 100% of the energy output. From our perspective, billions of light years away, an entire sector of the universe would simply go dark, star by star, as the civilization's shell of influence grew. The boat's void would, in this scenario, be a growing dead zone of utilized energy, leaving behind a wake of darkness where there once was light. Whether it is a natural quirk of cosmic inflation or a monument to an unfathomable intelligence, the boat's void stands as a reminder of the terrifying scale of the abyss. It is a region where the density of the universe drops to near zero, a place where the light of the Big Bang seems to have been swallowed by the sheer volume of the vacuum. It forces us to confront the reality that the delete key of the universe isn't always a violent black hole or a shredding big rip. Sometimes the abyss is simply the absence of anything at all. In the great nothing, the concepts of distance, time, and matter lose their meaning against the backdrop of an infinite, silent hollow, leaving us to wonder what other secrets might be hiding in the dark. Empty corners of the sky. The exploration of the cosmic abyss typically focuses on the pull of gravity, but the existence of magnetars reveals a different, more localized form of absolute erasure, the tyranny of electromagnetism. A magnetar is the skeletal remains of a massive star that has undergone a supernova explosion, leaving behind a core compressed to the density of an atomic nucleus. While a standard neutron star is already an exotic beast containing the mass of the sun within the diameter of a city like Manhattan, magnetar is a subset of these objects possessed by a magnetic field of incomprehensible magnitude. To quantify their power, we measure magnetic fields in Gauss, where the Earth's magnetic field is roughly 0.5 Gauss, and a common refrigerator magnet is 100 Gauss. A magnetar commands a field of 100 trillion, 10 raised to power 14 Gauss. This is not merely a strong magnet. It is a fundamental distortion of the electromagnetic force that dictates the behavior of all matter in its vicinity. The lethal reach of a magnetar is so vast that it redefines the concept of a danger zone. If a magnetar were to suddenly appear, at a distance halfway between the Earth and the Moon, the sheer strength of its magnetic flux would be sufficient to instantly scramble the magnetic strips on every credit card and erase the hard drives of every computer on our planet. But the physical effects on biological matter are far more nightmarish. If a human traveler were to venture within 1,000 kilometers of this celestial engine, they would not merely be crushed by gravity, they would be dissolved by the field itself. At this proximity, the magnetic force becomes stronger than the chemical bonds holding your molecules together. The atoms in your DNA, which are normally spherical or elliptical, be violently stretched and compressed into long, needle-like cylinders. Your molecular structure would lose its ability to function, and your body would effectively turn into a stream of polarized mist. Aligning itself with the magnetar's invisible field lines, the volatility of these objects is manifested in the terrifying phenomenon of starquakes. Because the magnetic field of a magnetar is so powerful, it is inextricably linked to the star's rigid crust, which is composed of an ultra-dense lattice of iron nuclei. As the magnetic field shifts and twists under immense internal pressure, it puts a titanic strain on the crust. Eventually, the crust reaches a breaking point and snaps. This starquake, though it may only shift the surface by a fraction of a millimeter, releases a burst of gamma radiation and X-rays that defies human calculation. A single major flare from a magnetar can radiate more energy in 1/10 of a second than our sun produces in 250,000 years. In 2004, a flare from a magnetar named Escher, 1806-20, located 50,000 light-years away, so powerful that it physically impacted Earth's upper atmosphere, partially ionizing it from across the galaxy. Magnetars serve as a grim reminder that the abyss is not always a silent hole in space like the boat's void, or a slow-motion trap like the Great Attractor. Sometimes the abyss is a screaming, high-frequency engine of pure energy. These stars represent the absolute limit of what matter can endure before it is surrendered to the field. They are the universe's deadliest magnets, acting as cosmic sentinels that guard the boundary between matter and energy. In the presence of a magnetar, the very building blocks of life are rendered obsolete, proving that in the deeper reaches of the cosmos, the laws of chemistry are merely a suggestion, easily overruled by the raw, unfettered power of a collapsing star's ghost. The concept of strange matter represents a transition from the astronomical threats of gravity and electromagnetism to the microscopic, subatomic horror of total ontological conversion. To understand this perfect form of matter, we must look into the core of a neutron star, where the pressure is so great that atoms have long since collapsed. In these hearts of darkness, the boundary between individual protons and neutrons dissolves, creating a soup of quarks. While ordinary matter is composed of up and down quarks, the extreme environment of a neutron star may facilitate the creation of a third type, the strange quark. The result is strange quark matter SQM, a substance that is theoretically the most stable state of matter in existence, more stable even than the nuclei of the atoms that make up our bodies, our world. In our stars, the existential terror of strange matter lies in its status as the ultimate cosmic infectious agent. Because SQM is more stable than ordinary matter, it exists in a lower energy state. According to the laws of thermodynamics, nature always seeks the path of least resistance, the lowest energy state possible. Therefore, if a droplet of this substance, known as a strangelet, were to escape the crushing gravity of its parent neutron star and make contact with ordinary matter, it would act as a subatomic catalyst. It would trigger a phase transition, forcing the nuclei of ordinary atoms to dissolve and rearrange themselves into the more stable, strange configuration. This is not a chemical reaction or a nuclear explosion. It is a fundamental rewriting of the laws of material existence. If a stray strangelet, perhaps ejected during the violent collision of two neutron stars, were to collide with Earth, the results would be absolute and irreversible. Upon impact, the strangelet would begin a chain reaction at the subatomic level. As it touched the soil, the water, and the air, it would convert the atoms of our world into more strange matter, releasing a massive amount of energy in the process. In a matter of hours, the Earth would not explode, but rather condense. The entire planet would shrink from its current size to a hot, glowing ultra-dense sphere roughly the size of a large stadium. Every mountain, every ocean, and every living soul would be reduced to a uniform, lifeless slurry of strange quarks. The information of our history, our biology, and our architecture would be overwritten by a perfect and indifferent subatomic code. This subatomic plague suggests that the universe has a built-in mechanism for total homogenization. If the strange matter hypothesis is correct, then large portions of the universe's core may already be composed of this infectious substance. It creates a vision of the cosmos, where life and complex chemistry are merely impassable accidents, fleeting bubbles of complexity, waiting to be popped by a single wandering droplet of the absolute. In this scenario, the abyss is not an empty void, but a potential state of matter that seeks to rewrite the universe in its own image. It is the ultimate expression of the delete key, where the variety of the periodic table is erased and replaced by a singular, unchangeable, and eternal density. The concept of the Big Rip shifts the abyss from a localized threat into a universal mandate, transforming the very vacuum of space from a passive stage into a predatory force. To understand this final disintegration, we must look at the equation of state for dark energy. While the Big Bang was the singular moment where space, time, and matter erupted into existence, the Big Rip is the moment where the expansion of the universe becomes so aggressive that it turns on itself. This is driven by a hypothetical form of energy known as phantom energy. Currently, we observe galaxies moving away from us at an accelerating rate. But the Big Rip suggests that this acceleration is not a steady climb, it is an exponential runaway. If the density of dark energy grows over time, the repulsive pressure it exerts will eventually exceed every other force in nature. Gravity, electromagnetism, and even the strong nuclear force that glues the centers of atoms together. The descent into the Big Rip is a chronological countdown of disintegration that begins on the largest scales imaginable. Roughly 60 million years before the end, the first casualties will be the titanic superclusters of galaxies. The invisible threads of the cosmic web, once held together by the ghostly scaffolding of dark matter, will be stretched to their breaking point and snapped. The great attractor which once dictated the flow of millions of galaxies will lose its grip as the space between objects grows faster than gravity can bridge the gap. For an observer in the Milky Way, the night sky would slowly go dark as the rest of the universe is pushed beyond the cosmic horizon. We would be left in a terrifyingly lonely island of light, watching as the external universe vanishes into an unreachable distance as the end approaches approximately 600,000 years before the final dissolution. The violence of the expansion penetrates the boundaries of individual galaxies. The glue of dark matter will no longer be enough to keep stars in their orbits. The Milky Way will begin to hemorrhage its contents, its spiral arms unspooling into the emptiness. It is the death of the celestial neighborhood. Our sun will be torn away from their sister stars, drifting into a loneliness so profound that no telescope could ever find another point of light. Within the final months of existence, the pressure of expanding space will finally overcome the gravitational pull of planets. Solar systems will disintegrate, Earth will be flung from its orbit, and the stars themselves will physically expand and shatter as the gravity, holding their plasma together, is outpaced by the stretching of the vacuum. The true horror of the Big Rip occurs in the final minutes and seconds, as the expansion reaches the atomic scale. In a normal universe, the electromagnetic force is trillions of times stronger than gravity, keeping electrons in orbit around nuclei and holding molecules together. But in the final moments, the expansion of space-time becomes so localized and intense that it overcomes these bonds. First, planets and people are shredded into a fine mist of atoms. Then, the atoms themselves are ripped apart. Nuclei are separated from their electrons. And finally, the protons and neutrons are torn into their constituent quarks. This is the ultimate death of physics, where the fundamental building blocks of reality can no longer touch or interact. In the final 10 rest to power minus 19 seconds, the fabric of space-time itself, the very stage upon which the drama of the universe is played for billions of years, is shredded. At this point, the distance between any 2 points, no matter how close, becomes infinite. Causality collapses because no signal, not even light, can travel between any 2 particles. The universe becomes a collection of infinite, isolated points. In a void, where the concepts of here or now have ceased to function, this is the total dissolution of reality. A state where the universe has not just ended, but has been unmade. The delete key has moved from the center of the black hole to every single millimeter of the cosmos, leaving behind a silence so absolute that the word nothing is no longer sufficient to describe it. While the Big Rip represents a violent, kinetic destruction of the cosmic fabric, the heat death is a far more patient and haunting demise. It is the inevitable victory of the second law of thermodynamics, which dictates that in any closed system, entropy, a measure of disorder, and the unavailability of energy must always increase. In our current epoch, the universe is a vibrant engine of energy gradients. We have hot stars surrounded by cold space, a disparity that allows for the flow of energy, the formation of complex chemistry, and the spark of life. However, this cosmic battery is slowly and irrevocably draining. The heat death is the state where the battery is finally empty, and the universe reaches a state of thermodynamic equilibrium. The timeline toward this long silence is measured in spans of time that render human history a microscopic blink. It begins with the stelliferous era coming to a close. Over the next 100 trillion years, the gas clouds necessary for star formation will be exhausted. One by one, the lights of the universe will go out, red dwarfs, the longest-lived stars, will finally consume their last dregs of hydrogen and fade into cold black dwarfs, or galaxies. Once brilliant, swirling cities of light will become collections of stellar corpses, neutron stars. White dwarfs and black holes drifting in an ever-expanding, dark. At this stage, the universe is a graveyard of cold matter, and the distances between these remnants will have grown so vast due to dark energy that even the light from a neighboring dead star can no longer reach its peer. The next phase is the degenerate era, where even the solid remnants of stars begin to fail. If the theory of proton decay is correct, the very atoms that make up the planets and dead stars will eventually disintegrate over 10 raised to power years. Matter itself will simply evaporate into subatomic particles and radiation. Following this, the universe enters the black hole era. For an unfathomable duration, the only macroscopic objects remaining will be black holes. Yet even these ultimate delete keys are subject to the laws of thermodynamics. Through the process of Hawking radiation, black holes will slowly leak energy back into the vacuum. Over 10 raised to power 100 years, a number so large it exceeds the number of atoms in the observable universe. Even the most massive supermassive black holes will evaporate in a final, silent flash of light. What remains is the dark era, the final state of maximum entropy. The universe becomes a thin, cooling soup of photons, neutrinos, and leptons, spread so thin that they rarely, if ever, interact. The temperature across the entire cosmos will be uniform, resting just a microscopic fraction above absolute zero. In this state, there are no gradients, no heat sinks, and no way to transfer energy. Because work cannot be performed without an energy difference, nothing can ever happen again. Even time itself loses its utility as a coordinate. Without change, there is no way to distinguish one moment from the next. Universe becomes an eternal frozen museum of nothingness, a vast cold graveyard where the abyss has finally finished its work, leaving behind a silence that will never be broken. The end of the universe is a grand, abstract tragedy, but its most visceral chapter begins in our own backyard. For billions of years, we have viewed the sun as a benevolent provider, the steady engine of photosynthesis and the anchor of our clockwork orbits. However, stellar evolution is a zero-sum game. In approximately 5 billion years, the sun will undergo a catastrophic internal transformation. As it exhausts the hydrogen fuel in its core, the delicate balance between the inward crush of gravity and the outward pressure of nuclear fusion will fail. The core will contract and heat up, igniting a shell of hydrogen around it, and eventually forcing the sun to swell into a red giant. This is the beginning of Earth's final morning, slow motion execution, where our source of life becomes our ultimate consumer. As the sun enters this bloated crimson phase, its diameter will expand by a factor of over 200. Mercury and Venus, the inner sentinels of the solar system, will be the first to be consumed, their rocky bodies vaporized as they are dragged into the sun's outer plasma layers. From the perspective of Earth, the sky will become a canvas of nightmares. The sun will no longer be a distant golden coin, it will become a gargantuan, textured wall of fire occupying half the horizon. Increased luminosity will trigger a runaway greenhouse effect long before the sun physically reaches us. The oceans, the cradle of all terrestrial life, will begin to boil. sending vast plumes of steam into the stratosphere until the seas are entirely evaporated, leaving behind salt-encrusted basins and jagged tectonic scars. The horror of this transformation is compounded by a profound chronological loneliness. By the time the sun's outer atmosphere begins to graze the Earth's scorched crust, the window for biology will have closed billions of years prior. As the sun's heat increased during its transition, the Earth's atmosphere would have been stripped away by solar winds, exposing the surface to the raw, unfiltered radiation of the dying star. Humanity and every record of its existence its cities, its libraries, its digital monuments will have been reduced to ash and dust long before the final embrace. The Earth will spend its final eons as a sterile, molten husk, a glowing marble of lava orbiting a dying god that has outlived its worshippers. Eventually, the sun will shed its outer layers in a beautiful but indifferent display known as a planetary nebula, leaving behind only a white dwarf, a hot, dense stellar corpse the size of Earth. The remains of our world, if they are not entirely consumed, will drift in the cold dark as charred, lightless cinders. This local apocalypse serves as a microcosm for the greater abyss. It reminds us that even the most stable foundations of our reality are subject to the same delete key that governs black holes and the Big Rip. Our home is not a permanent sanctuary, but a temporary vessel in a universe that eventually harvests everything it sows. The transition from the violent, expansive phase of a red giant to the white dwarf era represents the universe's transition into its long-welled twilight years, when a star like our sun sheds its outer layers in a spectacular but indifferent display of glowing gas. Known as a planetary nebula, it leaves behind a core that has reached its final structural limit. This remnant, a white dwarf, is a bizarre state of matter where gravity is balanced not by the heat of fusion, but by electron degeneracy pressure. This is a quantum mechanical effect where electrons are packed so tightly that the laws of physics forbid them from occupying the same space, creating a pressure that prevents further collapse. White dwarf is effectively a diamond-hard stellar corpse roughly the size of Earth but containing the mass of an entire sun. A single teaspoon of its material would weigh as much as a mountain range, a testament to the crushing density of the abyss, even in its most stable forms. This era is the fate of 97% of all stars in the cosmos. As we move into this degenerate age, the vibrant, star-forming factories of the universe, the vast nebulae of hydrogen and helium gas will eventually run dry. Galaxies will lose their spiral luster, becoming dull, elliptical collections of fading embers. There will be no new births to replace the dying, and the ghostly glow of the universe will be provided by these cooling white dwarfs. Unlike our current sun, which bathes the solar system in a life-giving solar wind, where a white dwarf provides almost no warmth to any planets that manage to survive the red giant phase. Any remaining worlds would be locked in a state of absolute permafrost, orbiting a tiny, brilliant point of light that offers visibility but no heat. The white dwarf era is a period of profound stagnation. During this time, the universe's energy budget is in a state of terminal decline. While these stellar embers can glow for trillions of years due to their stored thermal energy, they are not generating anything new. They're merely cooling down, like coals in a dying hearth. This is the beginning of the slow, irreversible dimming of reality. In this era, The grand structures of the universe, the great attractor, and the cosmic web still exist. But they are increasingly populated by dark matter in the literal sense. Dead stars, black holes, and frozen rocks. The universe becomes a gallery of antiques, where the light of the stars is a memory rather than a current event. As trillions of years pass, these white dwarfs will eventually cool into black dwarfs, theoretical objects that have emitted all their stored heat and become cold, dark masses of carbon and oxygen. Because the time required for a white dwarf to cool completely is longer than the current age of the universe, no black dwarfs yet exist. They are the future ghosts of the abyss, the final state of the matter that once made up the stars, the trees, and our own bodies. This era marks the point where the universe stops being a place of change and starts becoming a place of endurance, waiting for the even slower processes of proton decay or black hole evaporation to finish the work. Of the delete key, the Big Crunch serves as the symmetrical bookend to the Big Bang, proposing that the universe's expansion is not an escape, but a temporary reprieve from the relentless pull of gravity. This scenario relies on the critical density of the cosmos. If the total mass of galaxies, dark matter, and gas is sufficient, the momentum of the initial expansion will eventually be exhausted. Like a ball reaching the apex of its arc, the universe will experience a moment of cosmic stillness before the inward fall begins. This is the Great Rebound, a reversal of the last 13.8 billion years of history. Initially, the signs of this collapse would be subtle, detected only by astronomers observing a blue shift in distant galaxies, signal that the objects in the deep sky are no longer fleeing, but are rushing toward us with increasing velocity as the contraction accelerates. The abyss changes its nature from a distant void to a suffocating presence. In our current era, the space between galaxies is so vast that collisions are rare. In the Big Crunch, the universe becomes a crowded, chaotic theater of destruction. Galaxy clusters will merge into superstructures, and the night sky will gradually become a solid wall of light as stars from neighboring galaxies crowd into our local horizon. However, the true terror of the Big Crunch is not the impending collisions, but the heating of space itself. For eons, the cosmic microwave background CMB, the residual heat from the birth of the universe, has been cooling. Long, harmless radio waves. During a collapse, this process reverses. The radiation is blue shifted back into higher energies, becoming shorter, hotter, and more lethal. In the final stages of the collapse, the background radiation of empty space will eventually reach temperatures that exceed the surface of a star. The universe begins to cook from the inside out. There is no escape into the dark because the dark itself has become a furnace. Atoms will be stripped of their electrons, and the vacuum of space will glow with a blinding high-energy intensity that vaporizes planets and dissolves stars into a primordial plasma. This is the abyssal fire, a state where the distinctions between matter and energy begin to fail. As the volume of the universe approaches zero, the temperature and density climb toward infinity, creating an environment that mirrors the first microseconds of existence. The final moment of the Big Crunch is the singularity, the same infinite point that exists at the heart of a black hole, but scaled to encompass the entire cosmos. In this moment, everything that ever was, every mountain, every memory, every rogue planet, and every black hole is crushed back into a single, dimensionless coordinate. However, some physicists suggest this is not the end, but a big bounce. They theorize that the laws of quantum mechanics might prevent a total collapse into nothingness, instead, causing the universe to rebound like a compressed spring. If this is true, the Big Crunch is merely the exhale of a cosmic cycle, a reset button that leads to a new Big Bang, and perhaps a new universe with entirely different laws of physics, forever repeating the cycle of birth and death in the eternal dark. This process marks the transition from a universe of things to a universe of radiation. In this stage of the abyss, the concept of a solid object becomes a relic of a forgotten past. There will be no planets, no dust, and no singular particles of mass left to define a coordinate in space. The universe becomes a lepton age, a thin, featureless soup of light and lightweight particles drifting through an infinite, ever-expanding vacuum. Because there are no longer any atoms to form complex structures, the concepts of chemistry, biology, and even mass lose their meaning. The scaffolding of reality has not just collapsed, it has been deleted at the most fundamental level possible. Philosophical weight of proton decay is the ultimate delete key. While a black hole crushes matter and the Big Rip shreds it, proton decay ensures that matter simply quits. It suggests that the universe is not just a place where things die, but a place where thingness itself is a temporary anomaly. If you were to wait long enough in the deep future, even the most legendary monuments of our civilization, if they had somehow survived the red giant and the freezing of the void would eventually vanish into a mist of light, it is the final victory of the abyss, a state where the universe returns to the same simplicity it had before the Big Bang, leaving behind an eternal, empty expanse where the concept of existence has no physical medium left to inhabit. The transition from a universe of matter to a universe of gravity marks the beginning of the black hole era, the longest and most desolate chapter in the biography of the cosmos. As the stars burn out and the very protons that compose solid matter dissolve into a mist of radiation, the abyss finally claims its total sovereignty. In this unimaginably distant future, the universe is no longer a place of light or chemistry. It is a sprawling, dark ocean populated only by gravitational pits. These are the last sovereigns, the only entities with enough structural density to survive the slow evaporation of the degenerate age. For a period of 10,100 years, a number so vast that it dwarfs the current age of the universe by a factor of trillions of trillions. These dark titans will be the only things left to define the coordinates of reality. During this era, the universe undergoes a process of radical simplification. The complex tapestries of galaxies, once held together by the ghostly scaffolding of dark matter and the migrations toward the great attractor, have long since vanished. What remains are isolated supermassive black holes, each reigning over a vast empty kingdom of space that expands exponentially every second. On rare occasions, two of these sovereigns will be drawn toward each other by the lingering threads of gravity. Their merger is the only event that can occur in this epocha. Titanic collision that sends ripples of gravitational waves screaming through the fabric of space-time. Yet these ripples travel through a universe that contains no eyes to see. them and no ears to hear them. They are ghost signals passing through a graveyard, echoes of a reality that has long since been deleted. The sovereignty of the black hole is absolute, because they are the only objects capable of recycling the final stray particles of the universe. Any rogue photon or wandering lepton that has survived the decay of matter will eventually be snared by the event horizon of a black hole, added to its mass in a final act of consumption. For eons, these dark pits will feed on the cold, thin soup of a forgotten reality, growing slightly larger even as the space around them grows infinitely more vacant. They act as the final archives of the universe, holding within their singularities the last traces of the mass that once formed stars. In civilizations, but even an archive is subject to the relentless laws of thermodynamics. The abyss ultimately turns even on its kings. Through the agonizingly slow process of Hawking radiation, black holes will begin to leak their mass back into the vacuum in the form of faint low-energy light. For 10 rests to power 100 years, they will sit in the dark, slowly evaporating, like puddles of water under a non-existent sun. In their final moments, these sovereigns will undergo a violent transformation. As their mass reaches a critical minimum, they will vanish in a final brilliant flash of gamma radiation. This marks the end of the black hole era. The last sovereigns depart, leaving behind a universe that is truly, finally empty a state, where the delete key has finished its work. And even gravity has no medium left to rule. The concept of Hawking. Radiation represents the final, paradoxical plot twist in the biography of the cosmos. For nearly a century, black holes were viewed as the universe's ultimate dead ends eternal. Inescapable prisons from which no information or energy could ever return. However, in 1974, Stephen Hawking demonstrated that when we apply the laws of quantum mechanics to the warped space-time around an event horizon, the abyss begins to leak. This process, known as the final evaporation, suggests that black holes are not static monuments of darkness, but are instead subject to the same laws of thermodynamics as a fading ember. They are slowly, agonizingly bleeding their mass back into the vacuum, ensuring that even the most powerful gravitational titans are ultimately mortal. At the heart of this phenomenon is the quantum foam of the vacuum. According to the uncertainty principle, empty space is not truly empty. It is a roiling sea of virtual particles and antiparticles that constantly pop into existence and instantly annihilate one another. However, if a pair of these particles emerges exactly on the edge of a black hole's event horizon, a cosmic tragedy occurs. One particle may fall into the abyss while its partner escapes into the void. To an outside observer, it appears as though the black hole has emitted a particle of radiation, because energy must be conserved. The cost of this emitted particle is subtracted from the black hole's own mass. Over incomprehensible spans of time, black hole literally sweats itself out of existence, transforming its massive gravitational bulk into a faint, freezing glow. The mechanics of this evaporation create a terrifyingly runaway effect. The temperature of Hawking radiation is inversely proportional to the mass of the black hole. A supermassive black hole, containing the weight of billions of suns, is colder than the background of space, evaporating at a rate so slow it defies human measurement. But as the black hole loses mass, it grows hotter. As it shrinks from the size of a galaxy to the size of a mountain, and finally to the size of an atom, its temperature skyrockets. What began as a silent, invisible leak becomes a frantic, high-energy scream. In its final seconds, a black hole that has reigned for 10 raised to power 100 years suddenly release its remaining energy in a catastrophic burst of gamma rays, a tiny firework that signals the death of a king. When the last of these singularities vanishes in a final flash, the universe crosses its ultimate threshold. The black holes were the last concentrated sources of energy in the cosmos, the final archives of a reality that once contained stars, planets, and civilizations. With their disappearance, the universe is stripped of its last structure. There is no more gravity to pull things together, no more heat to drive change, and no more matter to define place. The delete key has finally deleted itself. ... remains as a state of absolute eternal equilibrium, a thin, cooling mist of photons drifting through an infinite dark hollow. The abyss has reached its final form, a universe that is not just dead, but entirely empty of the potential to ever be anything again. The heat death represents the absolute victory of the second law of thermodynamics, silent and inevitable finale that converts the vibrant complexity of the cosmos into a featureless, eternal graveyard. To understand this state, we must first understand the concept of entropy. In physics, entropy is a measure of molecular disorder and the unavailability of a system's energy to do work. In our current era, the universe is a place of profound energy gradients. We have the searing, localized heat of stars contrasted against the frigid depths of interstellar space. This disparity is the battery that drives the universe. It allows heat to flow, chemistry to react, and life to breathe. However, every time a star burns, every time a planet orbits, and every time a thought occurs in a brain, a portion of that useful energy is converted into waste heat that can never be recovered. The heat death, or maximum entropy, is the moment that battery finally runs dry. It is the state where the universe has expanded so far, and its energy has been distributed so evenly, that the cosmic temperature is uniform everywhere. In this state, there is no hot and no cold. Without a temperature difference, energy can no longer move. This is the death and heat death. It is not the presence of heat that kills the universe, but the lack of a place for heat to go. It is a state of perfect, terrifying equilibrium, where the potential for any physical or chemical change has been permanently exhausted. The universe is not gone in a physical sense. The particles and the photons still exist, but it is used up. It is a machine with its fuel spent, sitting motionless in the dark by this stage. The abyss has consumed everything that once defined reality. The era of the last sovereigns has ended. The black holes have finished their long, hawking, radiation-fueled evaporation, and the iron stars have dissolved through proton decay. What remains is a lepton age where a few isolated electrons and positrons drift through a volume of space, so vast that they may never meet another particle for 1 trillion millennia. The temperature of the cosmos sits at roughly 10 raised to power minus 30 Kelvin, microscopic fraction above absolute zero. In this environment, the concept of time begins to lose its psychological and physical meaning. Without events, without changes in state, And without the flow of energy, there is no way to distinguish the past from the future. The universe becomes a static, eternal museum of nothingness. The horror of maximum entropy is its absolute finality. Unlike the Big Crunch, which offers the hope of a big bounce or a cosmic rebirth, the heat death is a one-way door. It is the ultimate expression of the delete key, because it deletes the very possibility of anything ever happening again. The universe remains as a vast, cold expanse of three-dimensional space. But it is a stage without actors, a book with no words, and a clock that has stopped forever. We are left with the realization that our vibrant, light-filled epic is merely a brief, improbable spark in an infinite timeline of darkness. The abyss is not just the end of the story. It is the final, unchangeable state of the medium itself. The transition from a universe of events to the eternal void represents the final, philosophical and physical dissolution of reality. In our current understanding of the cosmos, time is often described as the fourth dimension, coordinate that allows us to map the progression of cause and effect. However, in the realm of physics, time is fundamentally a measurement of change, the movement of a planet, the vibration of an atom, or the flow of heat. When the universe reaches the state of maximum entropy, this engine of change finally ceases. With no energy gradients remaining to drive a single chemical reaction or subatomic interaction, the universe enters a state of perfect frozen equilibrium. Without change to mark its passage, the concept of time ceases to be a functional part of reality and reverts to a meaningless, mathematical abstraction. This era is the ultimate hollow shell of the cosmos. During the stelliferous and black hole eras, the universe was defined by its occupant stars, galaxies, and even the dark pits of singularities. But in the eternal void, the actors have not only left the stage itself has become irrelevant. The photons that remain are stretched by the continued expansion of space, until their wavelengths are longer than the observable universe itself, rendering them effectively non-existent. The delete key has completed its work so thoroughly that there is no longer a distinction between something and nothing. In this frozen state, a trillion years is indistinguishable from a nanosecond. As there is no physical process left to record the difference, the horror of the eternal void lies in its staggering, infinite duration. Every event that has ever occurred, from the Big Bang to the birth of your first ancestor, to the evaporation of the last black hole, occupies only the tiniest, infinitesimal fraction of the universe's total lifespan. The vast majority of the history of the cosmos will be spent as a dark, cold, and silent expanse. It is a state of absolute stasis, where the laws of physics still technically exist, but have nothing left to govern. The universe becomes a ghost of itself, a silent monument to a story that has already been told, and a light that has been permanently extinguished. This brings our journey to its ultimate conclusion. We have moved from the crushing hearts of singularities to the shredded fabric of the Big Rip, and finally into the absolute silence of the eternal void. We are left with the realization that we inhabit a brief, glorious anomaly, a moment of light and complexity in a timeline dominated by the dark. The abyss is not just a destination. It is the natural, final state of the universe. Our existence, our science, and our memories are the cosmic play that briefly entertained the void before the curtains were drawn and the lights were turned off forever.